Hello, this is Ray, one of the program presenters in the Atchison Planetarium at Cranbrook Institute of Science, with a look at the pre-dawn sky for the week of August 17th. Mars is high in the south on the 17th, Venus is in the east, and the waning crescent moon is just barely above the east-northeast horizon at 5 a.m. Eastern Daylight Time. We've used the summer triangle in the past as a guide to other objects. At this time of the year, it's located in the west at 5 a.m. Remember Cygnus' swan? Cygnus appears to be taking a swan drive right to the horizon. Deneb, one of the bright stars in the summer triangle, and the tail of Cygnus, is high in the western sky. If we head down the neck of the swan, we'll eventually come to Albireo, the beak of the swan near the center of the triangle. If we travel back up from Albireo, we'll encounter a star named Eta Cygni. One of the most exotic objects in astronomy is near Eta Cygni, but don't bother to try and see it. It isn't visible. It's called a black hole. Black holes are some of the most bizarre and amazing objects in astronomy. Black holes have such a strong gravitational attraction that not even light can escape them. The existence of black holes was predicted by Albert Einstein in 1916, but it wasn't until 1964 that the first evidence for their existence was detected. During a rocket flight in that year, a source of intense X-rays was detected coming from the vicinity of Eta Cygni. The energy was coming from an object that was too small to be a normal star. It was the very first black hole to be identified. A black hole is created when a supermassive star comes to the end of its life and collapses on itself. Cygnus X1 is believed to have been created by just such a collapse around 5 million to 6 million years ago. Now, massive stars collapse regularly, but they don't all create black holes. When an average star like the Sun ends its life, it'll expand, become a red giant, and puff off its outer atmosphere into space. What's left will be a white dwarf star. There are many examples of this occurring. One of the most famous is the Ring Nebula. In the case of a more massive star, the outer layers collapse onto the core and rebound in an explosion called a supernova. The Crab Nebula is an excellent example of that. But what about supermassive stars? Well, the gravity in a supermassive star is strong enough to crush the protons and electrons together in the core, creating neutrons. If the neutron core is between 1 and 3 solar masses, the collapse will stop, creating a neutron star. Neutron stars are very small. They would measure about 12 miles or 20 kilometers across. Objects that small rotate very fast. Some neutron stars are located in the remnants of supernova explosions. The one in the Crab Nebula spins 30 times every second. A neutron star's energy is concentrated like the beam of a lighthouse that pulses across our field of view. Neutron stars are also known as pulsars. Neutron stars are so dense and so massive, 1 tablespoon would weigh more than 1 billion tons, or 900 billion kilograms, on Earth. However, if the mass is even greater, the force of gravity overpowers the neutrons. They're crushed into each other. The gravitational force is so strong, not even photons of light can escape, and a black hole is created. The place where the photons disappear into the black hole is called the event horizon. The event horizon is spinning 800 times per second, which is nearly half the speed of light. Cygnus X1 is a binary star system. There's a blue supergiant star whose material is being pulled towards the black hole. The material forms an accretion disk around the black hole. It's heated to millions of degrees and X-rays are emitted. A strong magnetic field causes a pair of jets to form and emit some of the energy into space. The gravity of the black hole distorts the shape of the blue supergiant into a teardrop. The mass of the Cygnus X1 black hole is estimated to be about 15 times the mass of the Sun. Black holes formed by the collapse of individual stars are relatively small. The Harvard-Smithsonian Center for Astrophysics believes the Milky Way contains a few 100 million stellar black holes. Larger, intermediate-sized black holes have about 50,000 times the mass of the Sun. They could form if stars in a cluster collide. The spiral galaxy NGC 4395 might contain an intermediate-sized black hole. The largest black holes are located in the centers of galaxies. They have at least 100,000 times the mass of the Sun, could have millions and billions of solar masses. It's believed most galaxies, including our Milky Way, have a massive black hole in their center. In 2018, the Event Horizon Telescope, which is an international collaboration that involves 8 worldwide observatories, released an image of the shadow of a black hole in the relatively nearby galaxy M87. M87 is about 55 million light-years away. It shows a jet of material being ejected from M87's core. This black hole is 6.5 billion times the mass of the Sun. But don't worry about close by Cygnus X1 pulling our solar system into it. It's 6,000 light-years away, so we're quite safe. Sunrise on the 17th is at 6:42 a.m. Eastern Daylight Time. At the end of the week, the 23rd, sunrise is at 6:48. Thanks for visiting and keep looking up.